What are servlet filters? So far we've discussed about the request, response and its corresponding life cycle of events. Here we will discuss about customization of request and response using filters. Filters are used to process the content in the request or response objects of servlets, and generally they do not produce the responses. These filters interrupt the request before the servlet was processed, and interrupt the response immediately after the request was processed or before the response sent to the client. It enhances the lifecycle process, and it can be used to perform various functions across the multiple servlets in a web application. We use filters to add features to existing servlet code, and we also create reusable functions to use in multiple web applications. For example, customize the authentication process using filter. As we discussed earlier, the filter intercepts the request and checks whether the sufficient permission was given to the user to access the requested servlet. So, we prevent the unauthorized user from accessing the servlet. Similarly, filters can be used to record the user actions, compress the output streams, and etc. Filters are very flexible because we won't write the filters within servlets. As an alternative, they are configured in the web.xml deployment descriptor. Here we are seeing a figure that illustrates the processing of a filter. In this figure, sampleFilter.java is the filter and sampleServlet.java is the servlet name. Here, we filter the request sent by the client and the response received by the client. I think now you've got a clear idea about the filters. Let's see how we can define and implement a filter. If we want to write a filter, we have to implement the filter interface. Let's look at the filter interface. Filter interface contains three methods, and they are init, doFilter, and destroy. The init method is called by the web containers to indicate the filter that it is available for service. We couldn't use the filter before this method was executed. The structure of the init method will be like this. Here we have the object of the filter config interface as a parameter. It is used to give any configuration parameters. The doFilter method is the heart of the filter, where we can write the processes for filtering. This method has three parameters, i.e. request, response, the object of filter chain. This method is also called by the web container. It does all the filter processes and calls the doFilter method on the filter chain object to check if any other filters are available to process this request. If any, it will pass the request and response object to that filter. Otherwise, it will do post-processing, i.e. filtering the response. Here is the signature of the method. Destroy method is the last method in the filter interface. This method is used to remove the filter from the service. The general form of this method will be like this. We can also use more than one filter for a servlet. Here is the diagram which shows the filter chaining. The request and response was filtered by the several filters. We can also use more than one filter for customizing a particular servlet. This diagram shows the filters F1, F2 and F3, and the servlets S1, S2 and S3. Servlet S1 was filtered by the filters F1 and F3. Servlet S2 was filtered by all the filters, and the servlet S3 by the filter F1 alone. If we want to process the request, i.e. to filter the request, we have to write the codes for processing before calling the chain.doFilter method. Otherwise, if we want to intercept the servlet output, i.e. to filter the response, we have to write the codes after the call to the chain.doFilter method. Let's see how to use these filters in the servlet in the next lesson. Sample program for Servlet filters. Earlier we have discussed the concepts of filters and methods in the filter interface. Let's see a sample program that illustrates the purpose of filters. In this sample program, we simply calculated the time required for processing the request. Let's look at how it was implemented. Here, TimerFilter is the name of the class that implements the filter interface. We have to define the doFilter method to define the processes required for filter. In the doFilter method, we can retrieve the current time before and after calling the chain.doFilter method. Store the values in the long variables as start time and stop time, respectively. Also, we can print the values of both the variables for our reference. Finally, we calculate the difference, i.e., the time required to process the request. Here we have also defined the init and destroy methods. Now we will see how to configure filters in the web.xml file. As like servlets, we have to define the filter and also provide the mapping for those filters. The filter element should contain a filter name and filter class element. The filter definition for the above filter will be like this. Here, timer is the name of the filter and the timer filter is the class name of the filter. We can also give the init params and the description element in the filter definition. The filter mapping element in the web.xml file is used to map the requests to filters. The filter mapping element contains a filter name and either a URL pattern or a servlet name, i.e., the filter mapping is done through a servlet name or through the URL pattern. The filter mapping for the above filter will be like this. Here we apply the filters to all servlets in this web application. Otherwise, we can also provide this filter for a particular servlet, like this. Here, timer is the filter name and the servlet we used here is sample servlet. Once we are done with configuring web.xml files, we are ready to execute our program. Let's execute any of the servlet in the web application for which we created a filter. Well, here we use the servlet. Now I enter the username and press the Submit button. It will show the resultant message. It's not important for us. Now we have to check the output by using the log files in the Tomcat. So, I open the logs folder under the installation path of Tomcat. In that, open the stdout file to see the output. Here, as we discussed, it prints the message, start time, stop time, and the time required to process the request. We have now discussed the basics of steps and the basic implementation of filters.